Hello and welcome back. In this video, we're interested in animating Scarfy, which means we're going to cycle through the sprite sheet and select different sprites for the animation as we update it from frame to frame. We're going to see how we can use delta time so that animating Scarfy can be frame rate independent, so Scarfy's animations won't speed up or slow down when the frame rate speeds up or slows down. This allows us to control the animation speed so that we can set a desired animation rate to animate Scarfy. Let's go ahead and get started. Now remember, we have a sprite sheet which contains multiple images of Scarfy. We can think of each one of these images as an animation frame. And we cycle through these frames every time we update the image. Now remember, Draw Texture Rec takes a rectangle as an input, and the rectangle has its own x, its own y, a width, and a height. Now the x and y are the local coordinates for the sprite sheet, so it's really this x component here that determines which sprite out of the sheet we're going to draw. At frame 0, the x value is going to be 0. Because we want our rectangle's upper left coordinate to be the upper left coordinate of the sprite sheet itself. At frame 1, we're moving the rectangle over by the width of a Scarfy sprite, so x is w divided by 6. At frame 2, x is going to be 2 times w divided by 6, and at frame 3, it's 3 times w divided by 6. So we're starting to see a pattern here, and the pattern is the frame times w divided by 6. Here's how it looks in code. We can keep an integer to keep track of which animation frame we're on. Let's call this frame and initialize it to 0. Now each frame of the while loop, we're going to update that rectangle. Remember, we called this rectangle ScarfyRec, and ScarfyRec has its own x variable. Now remember the pattern. X should be equal to the current frame times w divided by 6, or that width of Scarfy. Now we're keeping this width value in ScarfyRec as ScarfyRec.width, so we can use this in our calculation. Now the first iteration of the while loop frame will be 0, so ScarfyRec.x will be 0. Now once we've given ScarfyRec.x its value, we can increment the frame integer by 1. This means next time frame will be 1, so ScarfyRec.x will be ScarfyRec.width. Now as is, frame is just going to be increasing by 1 each iteration of the while loop. So we're going to need to reset frame as soon as it gets larger than 5, since we only have frames 0 through 5 on the sprite sheet. So we can place an if check to see if frame is larger than 5, and if so, we'll simply set it back to 0. Let's see how this works in our code. So we're back in dasher.cpp, and we're going to add an integer to keep track of our animation frames. So let's add a comment first that says animation frame, and we'll call this integer frame and use braced initialization so that it starts off with a value of 0. Now let's go down into the while loop. Now, just before we draw the texture, I'm going to add a comment saying update animation frame. And here is where we're going to set the ScarfyRec.x variable. So first we're going to access ScarfyRec.x. Now what is it that we need to set ScarfyRec.x equal to? That's right, we're going to use frame and multiply frame by Scarfy's width, which is ScarfyRec.width. Now after we update the animation frame, we need to add 1 to frame. So we're going to say frame plus plus. And finally, if frame is larger than 5, we need to reset it back to 0. So we're going to say if frame is greater than 5, frame equals 0. Okay, let's hit run and start debugging and see how this works. Okay, here's our window, and here's Scarfy cycling through the animation frames. Now notice that Scarfy is running so fast we could barely see what he's doing. This is because we're updating the animation frame every single frame. And remember, we called set target FPS with 60, which means we're updating the animation frame 60 times per second. Now, that's a bit too fast, so we need to control this. So this will be your challenge for this lesson. You're going to make our animation frame rate independent and control how often we update the animation. Create a const float called update time. This is going to be the amount of time that should pass in between each animation frame. Create this outside the while loop, and we're going to initialize it to a value of 1.0 divided by 12.0, or 1/12. We would like to update Scarfy's animation 12 times per second, so 1/12 of a second should pass in between each animation frame update. Create a float called running time. This one won't be const because we're going to update it each frame by adding delta time to it. This will effectively keep a running time so that we know how much time has passed since the last time we updated the animation frame. Each frame, we're going to check to see if running time is greater than or equal to update time. This means it's time to update the animation frame. Now, inside this if check, we're going to reset running time to 0. And then we'll update the animation frame. So take all the code we just did under the comment update animation frame and stick it in this new if check. That way we'll only update the animation frame if running time is greater than or equal to update time. This is a bit more complicated than the challenges you've faced thus far, so don't get discouraged if you can't figure this out. Pause the video and give it a try, and then we'll do this together. Okay, so we're back in our program. Let's go all the way up to where we created our frame variable, and let's create a couple more variables. Let's make a const float called update time. And we're going to initialize it to 1.0 divided by 12.0, or 1/12 of a second. Now let's give this a comment. We'll say amount of time before we update the animation frame. Now let's make a float called running time. And we'll initialize this to 0 using braced initialization. Now let's go down into our while loop. Now here we're updating the animation frame. But before we do that, let's first update running time. So we're going to say running time plus equals dt. So each frame, we're adding delta time to running time. So let's comment this and say update running time. Now we just need to check to see if running time has surpassed update time. So let's say if running time is greater than or equal to update time. If that's the case, we need to reset running time. So let's say running time equals 0. And then we simply need to update the animation frame. So let's take our code for updating the animation frame and moving it into this if check. I'll go ahead and highlight these parts and hit tab so they're indented properly. So just to recap, we're updating our running time each frame by adding delta time to it. Then we're checking to see if running time has reached 1/12 of a second or greater. If so, it's time to update our animation frame, but we need to set running time back to 0, so our timer restarts. Then we set ScarfyRex x equal to frame times ScarfyRex width, and we update frame. And if frame has surpassed 5, we reset frame. Let's see how this works. Let's hit run and start debugging. And here's Scarfy, and it looks like his animation is updating 12 times per second, so this looks great. Excellent job. I'll see you in the next video.